Hello and welcome to TechTake. This is our one of our, I don't know what number it is now, but I think it's our fourth or fifth or sixth TechTake. So it's great to see attendees coming out again to watch these. We love putting them on. So great to see everyone here. My name's Chris Wilkinson. I'm from NCI. I'll be hosting today's TechTake. By far and away, not the star of the show, but I'll be here to help out wherever I can. So yes, very welcome, and we'll make a start here. Before we get started with today's content, I wanted to acknowledge that we're hosting today's TechTake from the lands of the Ngunnawal people here in the Canberra region. And I wanted to acknowledge the traditional custodians of the various lands in which you're all joining us today, and offer a special welcome to any Aboriginal and Torres Strait Islander people that may be joining us. We always pay our sincerest respects to the elders past, present and emerging, and we celebrate their ongoing significance to Australian culture and science. And I think that is summarised really well in this image here on your screens. This is the artwork that's adorning the Gardy supercomputer at NCI Australia. It represents the coming together of Western and Indigenous knowledge systems, and it was actually commissioned for Gardy by a local Ngunnawal artist, Lenice Letty Church, and we think it's fabulous, so hopefully you do as well. We're really proud of that, so we like to show that off whenever we can. So today's TechTake, once again, welcome. Seeing a few more attendees pop in now, which is great. So please use the Q&A for questions. Bottom center of your Zoom client, you should see a Q&A button, so please submit questions today via there. If they're about the session itself, if you're having technical difficulties, I'll try and help you there. If they're about the course content, I'll leave that to the experts for our Q&A section, which will be occurring at about 11:30 Australian Eastern today. I like to remind everyone there's no stupid questions. There really isn't. So please, we want to hear from you. Ask away. It can be about the course. It can be about the session content today. We'd love to hear that. But really, if you have any questions for the great team that we have in here today, pop them in the Q&A box. And yeah, we'd love to hear from you that way. Kindly note that we are recording these sessions, so if you do happen to ask a question or otherwise contribute to today's session, you may be recorded. So just keep that in mind. You should have received a notification about that already as well. The recording itself will be available via NCI, via our Confluence instance. I'll put a link to that in the chat during today's session, so hold tight for that one as well. So who have we got today? Well, we've got a crack team from MathWorks, who are the organisation behind the MATLAB software, which you're undoubtedly familiar with. So we've got two international guests from MathWorks. We've got Louvair Walker-Hannon, who's a senior application engineer and team lead at MathWorks, and Heather Gore, who's a MATLAB senior product manager. Because of the weird time differences, I think they're on the east coast of the United States. We've decided to get them in via recording today. So they won't actually be joining us live, but they put together this fabulous recording, which I'll be playing out to you in just a moment's time. I hope you enjoy that. We have two local guests from MathWorks who are actually here live, which is great. Peter Brady, who is an application engineer, and Bradley Horton, part of the academic customer success team at MathWorks. And if you were joining us back in June, you may have seen this team already before. We had a great training session. I think it was in June with the team from MathWorks, so it's great to have them back here today. So the content for today, I've tried to summarize it as best I can here, is deep learning workflows on clusters and clouds. So you'll be able to see how engineers and scientists who work on AI projects know when to move some or all of their development to clusters and clouds. That's basically what we talked about today. But we'll also be looking at the cloud options that MathWorks provides and the advantages they have across the development stages of a system based on AI. So lots of content to cover today. I won't keep it for too much longer. In fact, we'll go ahead and make a start now. We've got a couple more attendees have just come in, so that's great to see. The video I'm about to play is a little bit quiet, we've noticed. So if you want to boost your volume up a little bit on your computer at home, please do so. Just remember to turn it back down when we come back, because it might be really loud. But hopefully you have no problems with that. I'll go ahead and play this now. If you have any problems with it, please let us know through the Q&A and chat. Probably through the chat if there's any technical issues, but there shouldn't be. Anyway, that's enough from me. We'll see you on the other side for the Q&A session. Thank you very much.
Hi, everyone. Thanks for joining us today. We're going to talk about deep learning in the cloud. My name is Heather Gore. I'm a product manager for MATLAB in the area of data science and deep learning. And I help a lot of users get started, especially integrating deep learning networks into their systems, often including the cloud. And I'm joined by Louver Walker, who's going to get us started to begin our discussion.
Thank you very much, Heather. Hello. As Heather pointed out, I'm Louver Walker-Hannon. I'm a senior application engineer and team lead, where as a part of my role, I do a lot of customer facing, and I typically interface with customers who implement AI as a part of their workflows. And I do some similar work to Heather, and I'm going to highlight the usage of AI with these customers, as well as how they've used AI in the cloud. Next, what we're going to see is we'll talk about examples we worked on to help understand when and how to use the cloud in your AI work as a part of this presentation. And with that, I'm going to continue. So, what can we do on the cloud? It seems as if anything and everything. This is important, especially when considering deep learning / AI applications. If you notice in the slide, you can see that you can implement all of these tasks in the cloud. It could be running deployed models and some for training the models before they're deployed. As a part of today's presentation, we will have the following topics that we plan to cover. We'll discuss different ways of storing and getting access to data, training and tuning models using parallel processing, GPUs, and deploying, or using the models in a system also running on the cloud. We'll use examples to talk through, but first, let's ask an important question. Why would you use the cloud? We hear about cloud a lot, but let's be clear about the reasoning when it comes to AI especially. Deep learning models involve lots of data, training time, and computational resources. Typically, when we reach for the cloud, when we are limited by what's in our hands, when your laptop just won't cut it, and you need resources, data storage, GPUs to train your networks, and finally, to share your results. When I think of the cloud, I think of access from anywhere and everywhere. There are common workflows that are often used to approach cloud development and deployment. Of course, the workflow typically depends on the application. So Heather and I will share examples of why and how we use cloud resources in our work. We will provide an overview of these examples coming up next. In my particular examples, these are related to hands-on deep learning workshops, and we have used quite a few resources to help us host many workshops, especially over the past 2 years. Cloud was most definitely involved. For instance, the Pocket AI and IoT workshop, where the workshop participants were in different physical locations, but they were able to collect data from their phones as they moved around to collect their motion. And then after they moved around, we used a model, a machine learning model, to classify their activity into 3 different categories. So the categories were walking, running, or laying down. And then in the deep learning and IoT workshop, this entailed using IoT, the Internet of Things, to gain insight into what was occurring with data exploration in various locations. For example, individuals were placing different objects in front of their web camera, and there was a deep learning model that was used to help identify and classify what were those objects. Once those objects were classified, there was a histogram created to help display the categories of the different objects that were classified based on what the workshop participants were pointing at the camera at that time. Cloud was important in both of these cases, especially with the data come from the participants' devices and being used in the system. There's another good example of using cloud resources, and that's with another workshop. That workshop is the Do You See What I See workshop. So in this particular workshop, you have the participants who are now using deep learning networks. So we need to think about access to hardware such as GPUs. This workshop entailed the participants classifying poses. And after the poses were classified, we were trying to explore if the classification results changed based on the background scene changing. In order to run the deep learning model for pose estimation, it was extremely beneficial to be able to use a GPU so running the model could be done efficiently. This workshop has been presented to audiences worldwide, just like the other workshops, where it was not guaranteed that participants had access to their own GPUs, and many people participated worldwide. The reason why I mention this is because my colleagues and I wanted to provide GPUs or parallel processing access for using this deep learning network. So everyone can follow along, try the techniques, no matter what device and hardware they physically had access to or didn't. We were able to provide equal access to educational and computational resources. I think that's pretty groundbreaking. Another good example that comes to mind is an app that Heather created to detect the type of food that you may see in terms of pointing your mobile device at that food. This type of app could be used for healthcare, nutrition, biotech. In this case, it was a simple classification of food using the image to display the result. But of course, it's never as simple as it sounds. The entire app runs on the cloud. The phone image is uploaded. Image is prepared and passed to the model. Classification is implemented and done, and then returned through the app or website. So all of these parts are running with different technology in the end, talking about the final result. But the big question is, did this work start in the cloud? So what we're going to see is, how did this work? So here's the approach. In the early phase, development took place locally on Heather's machine since she had a good GPU. But the data was in the cloud. And if she didn't have GPU access, it would have started by her getting one. The common process is to start small with a subset of data or classes to get an original network, then start scaling. All of that can be done whenever this makes sense and wherever. But scaling to more classes and tuning the model is where cloud resources really came into play. For example, since you now have, so if you look at the slide, we're using 101 classes versus the model that was built with 5 classes. All of the data and running experiments, you're going to need more resources, or it could take weeks or months. So Heather got access to multiple GPUs and trained, tuned, did all of this work in parallel, but finally deployed to the web. And if we see this video here, it worked. This is the result running on the web, hosted in the cloud using GPU to classify. I've always personally liked this example since it shows a little of everything when it comes to cloud. We'll use this and my workshop experiences to show examples as we continue this discussion. And we see the results on the slide. It's pretty exciting, I think. So this gives an idea of the example, which is also how we think of phases, not too different from a typical AI design process, like we just talked about in the food app. In our case, we're using different cloud resources in the workflow to assess the data, build the models, tune, and finally deploy. So we're going to see many stages of this workflow. Let's start with getting access to the data. This is always a good place to start. So we need data to build a model. This was one of the main considerations with the workshops, being able to get access to the data. It was important that the data be accessible to anyone, anywhere for the workshops. Recall, there were audiences from around the world attending these workshops. This is one bigger overall benefit of data in the cloud, getting access to data through a URL. And you can control the security if needed, and in many important cases, do so many other tasks. We specifically for the workshops used MATLAB Drive, where the pertinent content for the workshop was uploaded to a folder in MATLAB Drive, and then this folder was shared with the workshop participants. This was a streamlined approach for providing access to the data for the workshop without workshop participants needing to explicitly download content onto their devices or their machines. Another part of the workshop that entailed using cloud resources was the usage of the Internet of Things, IoT. IoT was used to transfer data to a channel for analysis, where the analysis entailed working with data not just from one of the workshop participants, but from all of the workshop participants from around the world. For example, the Deep Learning and IoT workshop entailed participants taking everyday objects, placing those objects in front of a web camera, using a deep neural network to recognize the objects, and then the labels from the recognition were sent to a channel via IoT. Once the labels were collected via channel from all the participants, a histogram was created to see what were the most popular objects that were recognized by the workshop participants. I'll admit, during a certain point in time, which was interesting to experience. It was powerful because being able to access the data from individual devices, then summarize in our app to visualize, was extremely powerful, especially with us being in physical locations that were quite different. It also helps when you have a system like this and are training models on that data to be closer to the computing. Sometimes this is even the same for the cloud platform, which helps with resource sharing, less marshaling data over connections. This is also an easy process. For example, Heather used an S3 bucket for the food images, and it's just a few clicks. The least straightforward part is the security keys, but you can follow the documentation for setting up these keys. I've also done this on Azure and other platforms. It's a similar process and really easy to do. Now, let's think about the next step, which may be less easy. So we'll get into more related to the model training process. So it's under the stage of AI model design. A lot of computational resources are used, even in the beginning. The design phase or prototyping phases are very iterative. Heather has a GPU, so it made that a little fast for her to quickly explore. This is why we really wanted to provide good hardware for our workshop attendees. No one needed to wait a long time for models to train when they want to try their ideas or explore new parameters or layers. There are a lot of options for getting these resources too, just for when you need them, not besides, for example, all the time, just like Heather. I think the hardest thing when getting started is figuring out what you need to really implement. So here we have this visualization in terms of how to build this, our starting point, and let's consider there are many options that are out there. It's really good to sit down and plan out. Think about how much time it may take to train your model. It's really about balancing the cost and needs for your problem. You can always start smaller and scale up too. This is helpful during the design phase, so you can figure it out as you go along. It's also important to think about what's easiest for you, for your organization or university. Different vendors. Options might be better, easier to set up. The same is true for GPU resources. So if we notice, we have this view of the different resources that we've seen mentioned not too long ago. Now, in the case of our workshops, we use MATLAB Online with a GPU for executing a deep learning model. Very easy to just give everyone a link. No need to contact their IT administrators for any special access. But we also could have used a VM, Docker, or even the deep learning container. What makes the most sense really depends on your application and goals. For example, these are the steps to connect to that container that was previously mentioned. So it's fairly straightforward. There's lots of documentation available. to help get set up. Then you can use the software you need. This video is showing a different example that was worked on running the container to help train semantic segmentation in MATLAB. This worked really well, and guess what? I was able to use the software as I always do, but this time using the container. And you see the video in action, just showing many of these steps. One of the items that I'm going to point out next is we have some more content. So this time around with the next content, I'm going to hand over the presentation to my colleague Heather, who's going to highlight AI modeling tuning. So that's all from me. Thank you.
Thanks, Lou. Of course, this is the design phase where we're creating the model, and now we're going to move into the next steps that we want to talk about, which is tuning. This is where a lot of resources are used since you really tune the network, do parameter sweeps, perform experiments over and over. So you're training models entirely over and over again to get the best one. So this is where it really counts. And if you look at this plot, this is where people spend the resources in the phase of a project. This looks about right. As you continue on the project, you're iterating, maybe, you're using your local resources and more as you scale up. And, again, this is kind of where we see the model design phase. You're doing your experimentation, and then you really start tuning. You really need that extra resources. And so this is where I definitely had to scale. I was able to get the compute I needed and GPUs to do the training on the cloud. And like we mentioned, there's a lot of trials in this case. In a lot of these cases, when running one model takes a long time, you can imagine tuning and running experiments can take a lot longer. One thing that helps a lot is using things like this experiment manager app in MATLAB and other tools to keep track. And you can also help choose how to distribute the model training, control the parameter sweeps. So that's really helpful. And then once you get everything set up, you can just use the resources you provision, run the app. And depending on how long you might take you, you might want to just run this as a job without all the interactivity, depending on how you like to monitor things. But of course, like before, we really need to decide on the best cloud setup for you. There are a lot of options. In this case, I chose, like I mentioned, the GPU. We could have used Docker containers, VM, even the one that Louver talked about before. We could have used that same container and just added resources. So this is just showing an example of, the process, identifying the instance, looking at, selecting the number of workers, setting that up in the back end, and then you can just connect your local environment, however you want to use that, to use those provisioned resources. So like I mentioned, I decided on the 4-node GPU cluster, and this just shows it running to tune in parallel on the setup. So this kind of wraps up our tuning part. Now we're going to talk about wrapping everything up and deploying our model for sort of the grand finale. There are lots of options, like we mentioned before. This really depends on how you want to use or share your model in the end. In the case of the workshops, the model could be run on your phone or on a device. In these cases, we have to really think about how to host it based on the problem. For example, this is that same food model that I trained for the web application running on a Jetson board. So it's, same model on a device and using that same code around it. And, just kind of demonstrates that you have lots of options on how you want to use this in the end. It's also something we really think about. MathWorks, it's really common for a lot of MATLAB users. So we provide apps and, really convenient ways to make that process very smooth, just kind of package everything up and, go to the next phase. Of course, we're talking about the cloud, so we want to, many of these benefits are very similar to what we talked about before. And we're sharing, we want to make it accessible, available, scalable for sure, depending on how big we want this to be, how broadly we want this to be shared. So you basically want to collect your steps into a function or two, and then package all of that up to be called outside of your development environment. Again, dependent on the goals, but something that we try to think about, try to make this as smooth as possible. You could even integrate different languages. A lot of times that's the case. And this is an example in the video showing how to wrap up your Python, C++, MATLAB code, just package it together to be called, outside of the environment. So it's a huge time saver. Something to think about as you're going through the process. Again, always want to think about the final results. In my case, I wanted people to use the website that I gave them. I needed enough behind that, but I didn't expect tons of traffic. So I used MATLAB production server through AWS. It's really convenient. And then a basic front end and JavaScript with a little Python. The nice thing is that once you get the resources you need from the cloud provider, it's pretty easy. Use the VM, upload things, integrate. This video shows what we're doing using the MATLAB production server. This is helpful. I mentioned model caching here. There's a dashboard that you can just select it. You don't have to enable that in your coding. You can just select, Redis cache here. So that's a really nice dashboard to help manage some of that stuff. And then in the end, you just link it with the front end that you're going to be using. So you can just call your model from there. Of course, security is something to always think about, but that's something that you can manage through the cloud provider and through production server as well. So the integration is pretty simple. You'll get a URL to your model, and then you can use it via RESTful API. In my case, through the web app. Again, similar to before, we just want to be mindful about security, what we need, provision the resources, and of course you can expand that as you continue. Last important thing in all of this is testing. We make things sound quite easy, especially the workshops. Trust me, we tuned and tested a lot. So this is something you really want to make sure works in the production environments. Of course, you always test your model and your code before sharing it, but it's really important to test in that actual environment with that URL that you're given. This is an example using the food project, using that app that I mentioned to deploy and compile it, and that just enables you to help test and set breakpoints and things like that. So really the big point here is to take advantage of anything you possibly can to help with this step. It will save a lot of time down the road. And there you have it. I was able to host publicly, classify all sorts of foods. Of course, more importantly, Lou and her teams gave many, many workshops, and lots of people around the world learned so much about AI and the technology. So we got to see the payoff of all the things that we were talking about. We really focused on the two examples that we worked on, but there are many others that are doing the kinds of things that we're talking about. You can find lots of information and advice out there, might be similar to something you're trying to do. I'd encourage you to take a look at the different cloud providers, different things like that. There are a lot of case studies that you can follow along with. I guess it's time to wrap up. We have learned so much in a short amount of time. We talked briefly about the different steps with data, training our models, designing them, tuning and running our experiments, and then finally deploying our models all in the cloud. Of course, there's always more to learn. You can find links, intro materials, recipes, reference architectures, all that kind of stuff on GitHub. And also you can even join our workshops or catch a recording to see how it's done and learn more about the technology. I really want to thank everyone for joining us today. It's been a pleasure. Thank you, Louver, for sharing your examples and your important work with everyone. And we hope you join us in the Q&A and stay in touch. Thank you.
Thank you. Take care.
So, welcome back, everyone. Hopefully, that all went well after those couple of hiccups at the very beginning there. I once again apologise for that. I might have been trying to be a little bit too clever there with our Zoom production quality, trying to get that playback as smooth as possible, and forgot some basic steps like sharing the sound. So once again, I apologise for that. But hopefully that was all okay in the end for everybody. Thanks for sticking around. I wanted to pass this on now to Peter Brady and Bradley Horton from MathWorks here in Australia. And Peter, I believe you had just a couple of
Yeah,
comments.
yeah, for sure. Look, I just want to really reiterate. I do a lot of this in practice, mainly with commercial side, and Brad can support me from the uni side. But I want to really reiterate some of the points that Heather made. It's really just when you're working on these projects, take your time. It's very easy to burn a lot of cloud resources very quickly. And sort of test and scale quite slowly. Don't just jump straight into the deep end, right? I think that's the number one thing where I see a lot of projects fall over, is going too hard too fast. And then the other thing I want to say is, think of cloud as a very generic concept, particularly here in education settings. Like the Guardi resource we have here that's a cloud, right? You've got you have university HPC centers at your respective institutions. I think of cloud as not just an AWS or Azure, but any sort of facility you have access to that you can use that is not your desktop machine. So think of this in the most broad possible terms, really, and don't be limited to think must be AWS. Think Guardi, think your local HPC, Pawsey over in WA. There's lots of these facilities around at your disposal.
Yeah, I think those are really important points, especially in the local context we have here. We're quite blessed with what we have available in Australia as far as high performance computing and cloud and that sort of thing. So, yeah, as Peter was saying, make sure you reach out and have a look at these facilities. NCI with Guardian and then Pawsey with their machines and their brand new hardware that's being spun up soon. Should make a really big difference.
And anything called Quokka has got to be cool, right?
Right, it's got to be cool. Yeah, I can't wait to see more about that. Really excited to see what they come up with over there. Yeah, Satonix, it'll be great. So yeah, if anyone's interested in that sort of hardware, make sure to check that out. And of course, with NCI with Guardi, a sensational machine. You should be able to make a really good start on this. And I guess that leads me into a question I actually wanted to ask Bradley here about getting started. And if considering that many people here today might be new to machine learning, might be new to AI and deep learning, where can they find the resources? Where can they find extra resources to help with this sort of stuff? And where can they go for more information?
Yeah, nice. Thanks, Chris. So look, a couple of sort of responses to that question. So, there are a lot of choices these days with, alternative platforms for doing, AI in general. Lots of open source options. Python is incredibly popular, just for example. And often, when we sort of, have conversations with both academic and commercial customers about, MATLAB's capabilities in AI, it always comes down to, so what's so special about what the MathWorks has to offer? And this will tie ultimately to the question that you asked about, how do I get started with AI and MATLAB? So, from a historical perspective, I mean, we know that sort of, MathWorks has been very strong about 37 years ago with solving sort of matrix-based problems, yeah? And, that's sort of built upon signal processing sort of capabilities, control system capabilities, optimization, computer vision. MATLAB's been really, really good at solving those sorts of applied science and engineering domain problems. And all of a sudden, over the last sort of 12 years, MATLAB's capabilities in AI have grown. So now we're sort of at the stage where, we've got that really good foundation of sort of domain-specific solutions that are ready to go, your signal, your computer vision. And now, over the last decade and a bit, we've been building layer upon layer of our AI capabilities. So how do people sort of get started with it, ultimately, is your question. Well, most of our users do like the sort of usage choice. And what I mean by that is, folks that aren't necessarily sort of experts in AI appreciate things such as our app-driven workflows. Being able to launch an app that guides you through the process of designing, say, a pattern recognition solution. Launching an app that guides you through the process of performing a transfer learning task using a deep convolutional neural network. So those sorts of app-driven workflows are really, really designed for that sort of new user, either new to MATLAB or new to AI. And then, from there are sort of, workflow choices that sort of typically extend into more programmatic sort of ways of solving problems. But that choice is really important. So with that as the backdrop, the answer to your question is my very first sort of recommendation for getting started with, AI with MATLAB, even before you start sort of looking at, the cloud sort of solutions that you bolt onto it. So I'm going to guess that most folks that are on this call today from academia, 33 out of the 40 universities in Australia have campus licenses. So the significance of that statement is that not only do you, get the keys to the candy store in terms of, all of the software and products that we make, more importantly, you also get access to our virtual training course library. And at last count, we had around about 18 of these self-paced courses that people can log in and sort of learn from and practice. It's not just about the audio and the static text. It's about an interactive sort of training experience. So we have sort of self-paced courses on machine learning, self-paced courses on deep learning, and reinforcement learning too. So the bottom line on top, I'm sorry for sort of hogging the airway, but I'll converge really quickly. The bottom line on top, the answer to your question, Chris, is I definitely recommend that you check out our offerings in MATLAB Academy, which is our library of self-paced training courses. For an investment of a couple of hours, I think you'll get really good exposure to what we can do. More importantly, how we do it and what sets our sort of AI offerings apart from some of the alternatives. Thank you.
Yeah, thank you so much, Bradley. That was a very comprehensive answer. And I guess I would add to that something I mentioned in the beginning was that the courses, the course that MathWorks ran with NCI earlier in the year was another a great addition to that whole idea of that self-taught learning experience. And hopefully NCI and other places will be able to offer more of that in the future. I think that was very helpful to a lot of people who are new in this space. But certainly those self-paced learning opportunities that are available would be great for anyone that's getting started. I could totally see that. If anyone else has a question to ask, I just wanted to let everyone know, please feel free to use the Q&A in Zoom. Or just pop it in the chat if that's easier. If we'll be here just for a little bit longer, so if you have any questions for our team here today, please shout out and we'll be able to answer those. Maybe this is more something to comment about, but there was something I really liked during Lou and Heather's presentation. Then was they kept coming back to the idea of being accessible, available, and scalable. And do those three ideas, do they underpin a lot of what happens, what your ideal circumstances behind the work that you do? How much is it it's more like a mantra than anything. So how does that drive your innovation as far as MathWorks, and how does that help people ultimately?
Well, I'll take a stab at that first up. From my perspective, so I'm reiterating this, I work in commercial land, right? You might have the best model in the world, but if it's on your desktop, it's dead, right? Like I work with traders, mining companies, finance companies, automotive, you name it. We work in those industries. But if you've got the best model on your computer, it's dead. So accessibility and transference, like you need to be able to take that step and report that model, move it out into production. So I think it's critical for any system. And that really does drive a lot of our innovation in our workflows to be able to take that model and deploy it. And that deployment can be as simple as giving a MATLAB binary to another MATLAB user and say, load it. Or it can be all the way through to generating embedded C, highly optimized embedded C code to run on an embedded processor that you're going to stick on a production line and do automatic classification of pallets as they come underneath you. You're going to automatically classify those pallets as they come underneath you on the conveyor belt. So for me in commercial land, it's critical, absolutely critical, probably even more so than a research context, because it's value for money. It's time. You're spending time developing these models. You have to get it into production to return that value to your organization.
Yeah, I think that's a really good point there, Peter. Thank you. I guess one other thing that I was made a note of during the presentation, and I think it comes back around to accessible, available, scalable. And it was a little bit. It was perhaps just summarised rather than explained further. And perhaps yourself or Bradley might want to build on this. Was the idea of security, and how do you balance being accessible and available, but also that necessity to have a secure system and secure resources? How do you approach that?
That's tough. All right. And then at the end of the day, it becomes a value decision for the end user, because the most secure network possible is something that our defense customers run, where it's an air-gapped network. It's in a different room. You have to get a USB stick approved by security to take through the door to connect to it. But that's just unusable in the real world. So my advice normally when I'm working with customers is think about it up front, work out what your needs are, and it's a balancing act. There's not going to be a right answer. There's going to be appropriate for your situation, and monitor and review as the threat level changes. The advantage of using a lot of systems like Guardi is that we get to say, Chris, there's a vulnerability in the underlying operating system. That's your problem to deal with, not mine. So there's a little bit of that in it, but you have to be aware of it. And to be honest, the most common weakness is you and me. Most exploits are password driven. Most of them are social. There's very few big 0-day exploits in the wild at the moment, and when they come out, they make a lot of news. But most everyday hacks are driven by spear phishing attacks or user social engineering attacks. So it's really, we are the weak link. Use secure passwords, keep a monitor of your threat level, and design up front to balance your needs.
Yeah, I think those are great tips for just about for any type of work.
Pretty much, yeah.
Yeah, it's all the basics, right? Don't write your password down. Make sure.
Don't write your password down. Yeah, use it. Don't repeat your password. There's so many great password managers available there for free. Start using one.
Yeah. I can see Bradley's put a comment in there today. We would love to know if you're currently using MATLAB for AI. So if you're using MATLAB for AI, shout out. We'd love to hear from you. Maybe you can have your own thoughts about what we've been talking about today. We'd love to have that contribution. Yeah, it's again, this is more of a comment than anything from me, and I think this might be wrapping things up now. But thinking super duper big picture, long term, I like the idea of this equal access to these computational resources. I think Lou was talking about this earlier on about how it's an accessibility problem that's solved by having GPUs in the cloud, right? You don't have to have a workstation. You don't necessarily even have to have special access to some sort of cluster. You can go on the cloud and there's GPUs. You provision those resources and you can go ahead. Does this open up opportunities for even a layperson like myself, for example, who's not a researcher, who's not part of this big commercial engine, to start using resources like this and to start moving towards using AI in the cloud for something? Like, does this bode well for your everyday user, your everyday person being able to do these type of things?
I think so. I think this is where it's heading, and certainly with the industrial users I work with, I'm really thinking of it as the second. I personally think of it as the second wave of AI, where it's coming out of the domain of the data scientists and it's coming into the domain of the product specialists. And product specialist is what I use as a very broad term. That you could be a doctor working on blood, a hematologist. You could be a packer in a warehouse, right? But you have the domain knowledge of your expertise in your area, but you may not be a data scientist. So I see these tools, and I think we're at the forefront of these with our app-driven workflows, is we're allowing those non-data scientists to drive the AI techniques and tools into their workplace and really pushing it out further. So that's what I see, and I'm starting to refer to it as the second wave of AI moving out into normal people, not data scientists.
Second wave of AI, as coined by Peter Brady.
You heard it here first. Yeah.
Has a good ring to it. I like it.
But you can understand conceptually. That's what I'm thinking. We're seeing
Sure.
a real shift, and I see this commercially every day. We're seeing a real shift moving from and to a university context is when I was finishing up my PhD. It seems a lifetime ago, about 8 years ago. It was data science was hardcore. It was in the IT faculty, in the mathematics faculty. It was seen as a pretty hardcore growth area. And now it's not. It's out. It's being applied in engineering. We've got people in the humanities doing deep learning processing of text analytics and data mining those research catalogs in libraries that are becoming publicly available. And it's a real shift moving out of that specialist area and being applied in practice.
Yeah, and personally, I think that's really exciting for people to be able to have this opportunity to try and engage with all this computational power and trying to find a way for your everyday person, like you said, the factory worker or whoever it might be, the doctor, trying to use these resources effectively and not needing to lean on a data scientist necessarily to do the work. They can do exactly as what was described by Lou and Heather, as you can just go on, provision the resources and go for it.
And to be perfectly frank, I see better results, right? Because you can bring your understanding of that physical system or the process in the packing plant or the biochemistry, right? Rather than just a pure data science perspective of just looking at columns of numbers, right? You bring that understanding of your area, your research speciality, and apply a tool.
I see Kiawa has was a question in the chat here. It was question/comment. I haven't seen any of our HPC users using MATLAB for AI. Is there some nice tutorials to look at somewhere? And I think this is something we covered just a little bit earlier, but perhaps if someone can drop a URL or some advice to Kiawa there on how to get access to some tutorials would be good. It might depend on what sort of licenses are available at whatever institutions have got a hookup with that. But, yeah, it'd be great if we can get that sorted.
Yeah, we'll. I think Bradley's going to pull that up as we go. But we have, as Bradley's already mentioned, we have a lot of resources already available. We've got some great discovery pages at MathWorks.com just to get started on big pictures. And a lot of our on-ramps, or all of our on-ramps, I think, are free actually anyway, depending on what your licenses are. But most of all the campus-wide people have access to a lot of deep training resources already. So just mathworks.com and go to, I think it's matlabacademy.mathworks.com is a great place to start.
The MATLAB Academy. Yeah. That would be, I think that'd be a great start if you do have those campus licenses available. And like I said earlier, hopefully NCI and other organisations similar will be able to provide more of this, more of this type of training in the future. Yeah, go ahead and have a look and see if you can't find those links there, Kiawa. I think that'll be very useful.
Yeah. And I think if you do get stuck, reach out to Bradley via Chris, and we can probably assist you with some more there if you get stuck.
Yeah, that's a good point. Yeah, I should actually open that up to anybody. If you do have any questions after today's webinar, feel free to talk to us directly at NCI, and I can pass any questions on from there. I'll just put the email address in we're using at the moment. I see Morgan's just put in a URL there as well.
Thanks, Morgan.
That's great. That's the email address for NCI training team at the moment. So if you do have any questions after today's webinar that come to mind, please feel free to email through, and I'll have a look at those and pass those on. But we're getting closer to 12 o'clock, so that means it's just about lunchtime here on Australia's East Coast. So I think that might about do it if there's no more questions. Yeah, I would like to sincerely thank Peter and Bradley, as well as Lou and Heather, who provided that excellent excellent presentation earlier in today's webinar, and thank you everyone for attending and interacting with us today. Like I said, the recording for this will be up on NCI's Opus page. I didn't put a link in for that, but if you go to that URL at some point later today or tomorrow, you should see those links under the NCI Presents TechTake training part of that website. So you'll be able to review the content from today there. I think that might be it though. Yes, thank you so much to everyone from MathWorks for putting on such a great presentation.
Our pleasure.
All right, everyone go get some lunch, and we'll see you next time.
Very easy. Thanks for your time, Chris. Thanks, everybody.
Thanks,
Thank you,
Chris.
everyone.